class. Today we're going to be learning lesson 3-2 in your textbooks, which is teaching us how to use parallel lines and transversals in some of our proofs, okay, and how we can find out different information based on diagrams and using these proofs to help us out. So the first thing that we're going to talk about is postulate 15. We're going to add this to our repertoire of different postulates and theorems, properties that we've listed. And what it says is, it says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So why don't we draw a picture to help us out with this? We're going to go ahead and draw for ourselves two parallel lines. And a transversal. Transversal means a line that is cutting both of those. And the way that we show that they're parallel, again, is by having that tiny little arrow on both of those lines that are parallel to one another. It's kind of like a little extra arrow. And let's say that I have angle 2 and 6, just as some examples. Those are both corresponding angles. And what we're told from this postulate is that those angles should be congruent. So angle 2 should be congruent to angle 6. Likewise, other corresponding angles in this diagram are also congruent to one another as well. So what I have here is I have another picture, and it says 3 of the numbered angles are also 120 degrees. So in my diagram, I have one of these angles already given that it's 120 degrees. And out of these remaining 7 angles, 3 more of them are also 120 degrees. So what I want you to do is to identify the angles and explain why those are also 120 degrees. So looking through here, I think that angle 5 is also 120 degrees. So I'm going to say that the measure of angle 5 is equal to 120 degrees. And the reason why is by the postulate that we just wrote up above, by the corresponding angles postulate. Both of these angles are in the exact same position. They're corresponding, so they should be congruent, which means that their measurements are equal. And so if I know that, let's see what else I know. Well, angle 4 right here is vertical angles with that 120 degrees. So the measure of angle 4 should also be 120 degrees by the vertical angles postulate. Okay, so I found 2 of those angles. The third one, I think as I'm looking, now that I know what 4 is, I could see that it is a corresponding angle with angle 8. So I'm going to say that angle 4 and angle 8 are corresponding angles. So, by the corresponding angles postulate, the measure of angle 8 should also equal 120 degrees. This is something that you can definitely do on your own, is to just take it one step at a time and try to isolate a specific angle and give a good reason why you think that that angle is a particular measure. Okay, so let's move on. We're going to talk about 3 different theorems that we have now. The first one is titled the Alternate Interior Angles Theorem. So probably, as you guessed, it's going to deal with alternate interior angles. And what it says is, if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So why don't we go ahead and draw ourselves a picture for this one. So I have my two parallel lines. I'm going to draw for myself a transversal. Again, I know that they're parallel because I'm going to draw kind of that double arrow on both of those. And alternate interior angles. So in this diagram, I'm just going to choose one pair of them. I'm going to choose angle 4 and angle 5. And what it's saying is that these alternate interior angles, when those two lines are parallel, should be congruent to one another. So angle 4 is congruent to angle 5. All right, that's all that that theorem is telling us. Let's look at the next one. Theorem 3-2 says alternate interior angles, or alternate exterior angles theorem. So if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So the time before in our diagram, those angles were interior, and they were the alternate ones. Now we're looking at alternate exterior. So let's draw for ourselves another diagram. Let's draw two parallel lines and a transversal. I need to show that they're parallel. And let's just pick one pair of the alternate exterior angles. So how about we pick angle 1 and angle 8? Okay, they are on alternate sides of the transversal, and they're also the exterior ones. So by this theorem, angle 1 is congruent to angle 8. Okay, let's talk about one more theorem. This one is titled the consecutive interior angles theorem. And what it says is, if two parallel lines are cut by a transversal, then the pairs of the consecutive interior angles are supplementary. So let's see if we remember what that means. If I have my two parallel lines, again, you're going to get really good at drawing today. Hopefully you have your ruler out. And have my transversal. Draw to show that they are parallel. There we go. So if I have two consecutive interior angles, so let's say angle 3 and angle 5, what I'm told is that angle 3 and angle 5 are supplementary, which means that they add up to 180 degrees. So using all this information, why don't we go ahead and do an example? I drew a picture for you already, and in this example it says to write a proof using the diagram to find x. Okay, so over here I have one of these angles is 115 degrees. One, we're just giving it the name angle 4, and another of the angles says x plus 5 degrees. So let's logically go through how I can find x by giving a reason for each of my steps. So first, looking here, I can see that this 115 degrees is a vertical angle with angle 4. So I'm going to write that down. The measure of angle 4 should be the same as the 115 degrees. And the reason is the vertical angles congruence theorem. You may not know where to start with proofs, so just start with some things that you know from the diagram. Just talk about the diagram. What facts can you state? So if I know that, then I also know that the measure of angle 4 plus the x plus 5 should equal 180 degrees because of my last theorem right here. Right? They should add up to 180 degrees because they should be supplementary. So I'm going to write that down. The measure of angle 4 plus x plus 5, that angle, degrees, should equal 180 degrees. And that's from the consecutive interior angles theorem. Okay. So if I know that, why don't I do some substitution? I know that the measure of angle 4 is 115 degrees. So I'm just going to substitute that in there. And my reason is substitution. Okay. Now I'm just going to simplify what I have. By combining. Okay. So this is simplify. And in the end, I find that x is going to equal 60. And this is from the subtraction property of equality. And I'm done. I found out what x was equal to. Okay. Let's go ahead and do one more proof, and then we're going to be done for today. Here we go. This proof says that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Okay? That's what I'm asked to prove, is if I'm given that two parallel lines are cut by transversal, that the alternate interior angles are congruent. This latter part is what I need to prove. So why don't we go ahead, if you're given something like this and there's no diagram, draw for yourself a diagram. And you can go ahead and pick how you want to label it. So I'm going to just draw myself a diagram, and I'm actually going to give these lines some names today. So I'm going to call this line P, and this line Q, and this line T. You can choose whatever letters you want, doesn't matter. I'm going to show that they're parallel. Okay. And I'm talking about alternate interior angles. So why don't I just label one pair? I'm going to label this angle 1 and angle 2. And I'm also going to label a third angle down here, and you'll see why. So really, what I'm given, just from my description, was two parallel lines cut by a transversal. So I'm given in the beginning that the line P is parallel to the line Q. And what I want to prove at the very end is that angle 1 is congruent to angle 2. This is kind of like my thought bubble of what I'm being asked in the beginning example at the top. Okay? So why don't we use this information in this diagram to go ahead and organize a very short proof. I'm going to start with what I'm given, that P is parallel to Q. Okay, that's pretty basic. Looking at what I have, okay, I know that angle 1 is congruent to angle 3. Because of the corresponding angles postulate. Also, looking at my diagram, I know that angle 2 and angle 3 are congruent because they're both vertical angles. So why don't we say that? That angle 3 is also congruent to angle 2 because of the vertical angles congruence theorem. And so if that's the case, if angle 1 is congruent to angle 3 and angle 3 is congruent to angle 2, then I should be able to conclude that angle 1 is congruent to angle 2 because of the transitive property of congruence. And I'm done. This is all that we're going to do today, and this is very similar to the stuff that we're going to be working on together in class. So make sure that you have all of these theorems written down and the postulate, and when we come to class, we'll do some work together on all of them.